Alright, for this video we're going to talk about two more tools in our probability toolbox. We're talking about combinations and permutations. And this one is not something that's in your book. I'm not going to emphasize it a lot on the test, but I think it's important that you see it if you've taken a statistics class. So we use combinations to find the number of probabilities, or number of outcomes, sorry, or possibilities. I think that was the word I was looking for. Specifically, the number of possible groupings when order is not important. So for example, I work at a high school. If we're building a committee and that committee doesn't have a president, it's just a group of teachers that are all at the same level, this would be a combination. I'm selecting a subset of teachers from all of the teachers, but the order in which I select them doesn't matter because none of them have special jobs. All members of the committee are on equal footing, so whether I got selected first for the committee or last for the committee doesn't really matter to me. Permutations do the same thing, but they care about order. So an example for that would be if I'm electing a president, vice president, and secretary for an organization. The order matters. If I get chosen first, I'm president. If I get chosen last, I'm secretary. It matters to me whether I'm president or secretary. The order of selection is important. So generally, if when you're making this selection, all of the chosen things are going to end up in the same spot, that's a combination. If as you're choosing things, they're going to end up in different spots or with different roles, then it's a permutation. We're going to look at both, and I'm going to show you the formula, but I'm going to expect that you're using your calculator to calculate it. So don't panic if you're seeing scary math that you haven't seen before. So we're going to start with combinations, and we can see here that it says NCR. That's our notation for combination. C is for combination. The N is the total number of items. So in my example of selecting teachers for a committee, N would be the total number of teachers at my school. And then R is the number of items chosen. So if I'm building a committee of 5 people from all the teachers at my school, it would be 70C5. 70 teachers at my school. I want to choose 5 from that group of 70, and it's a C because the order I choose them doesn't matter. On the right side, we see a fraction that looks a little scary. And we see a symbol we probably have only seen in English class up to now. We see an exclamation point. In math, that stands for factorial. So we have n factorial divided by n minus r factorial times r factorial. So the question is, what does that n factorial look like? So I'm going to write some patterns so you can get a feel for what that's doing. So if I did 5 factorial, what I'm actually telling people to do is take 5 and multiply it by all the numbers less than 5 down to 1. So 5 times 4 is 20, times 3 is 60, times 2 is 120, times 1 is 120. So 5 factorial is 120. Yeah. 4 factorial would be 4 times 3 times 2 times 1, which would be 12 times 2, which is 24, right? 3 factorial would be 3 times 2 times 1, which is just 6. 2 factorial is just 2 times 1, which is 2. And then I'm going to give you two definitions. 1 factorial is 1, 0 factorial is 1. That doesn't make sense. That's okay. It's a definition, not something that you can calculate with a formula. So what we're doing is we're starting the pattern. This is how we start the pattern. So we would take n factorial, n minus r factorial, r factorial. Some of those are going to cancel, because you'll notice that r is usually smaller than n. I'm choosing a smaller subgroup from the total group. And so some of the things in r factorial are going to cancel out the things in n factorial. So when you evaluate this by hand, it's not as scary as the formula makes it look. But it's 2025. So on your graphing calculator, you're going to press Math. You're going to go over to the Prob menu, and then you're going to select option 3. So I'm going to do that on my TI-84 simulator. It'll look a little weird, but I want you to see what it looks like. So you'll notice there's a Math button beneath the green Alpha button. And then there's 5 menus across the top. Yours probably says PROB instead of PRB. And the third option down is an NCR. And you'll notice on my screen, it's asking me, what are the numbers for N and R? And it provides me with placeholders. If you are working with a TI-83 or an older model TI-84, you may need to enter the first number, N, that's 70, before you call the NCR from the menu. Because sometimes on the calculator, instead of what you're seeing here where it says 70C5, older model calculators, you would see 70 and then you would see NCR and then you would see 5. So you would do the 70 first and then call NCR and then do 5. It doesn't give you placeholders because it doesn't have the math type in its memory. We're going to do an example and then we're going to really quick look at permutations and then we will be done. So for this example, it says a researcher wishes her patients to try a new medicine for depression. How many different ways can she select 5 patients from 50 patients? So first thing I notice, I am making a selection of 5 from a group of 50. So this sounds like combinations and permutations, making a selection from a bigger group. And then I ask myself if order matters. And in this case, she's going to give all 5 patients the same medication. So it doesn't matter when I selected them, the order I selected them. So this is a combination. So we want to evaluate 50C5. And it is always the bigger number in front. Yeah, 50C5. I'm going to do it by hand, and then I'm going to do it with the calculator, just so you've seen both. So this would be n factorial divided by n minus r. 50 minus 5 is 45 factorial times r factorial. And I'm going to do something pretty cool. I know that 50 factorial and 45 factorial have all of the numbers that are 45 and less in common. So on top, that's going to leave me with 50 times 49 times 48 times 47 times 46, because 45 and down is going to cancel with the 45 factorial. In the denominator, all I'm left with is the 5 factorial, which is 5 times 4 times 3 times 2 times 1. And that's something a little less scary. If you wanted to do it this way, when you plug it in your calculator, make sure you remember to put parentheses around the top and bottom. I'm going to do that with you so that we can compare both methods. So let's start with manually. So parentheses around the numerator. 50 times 49 times 48 times 47 times 46 divided. Ooh, did I do that right? Do I have. Oh no, hold on. Sorry. I pressed the wrong button. And then same thing for the denominator, 5 times 4 times 3 times 2 times 1. And we get 2 million something. And then I'm going to do it manually. So remember to do probability calculations. I go math, I go over to probability, I select option 3, and I'm doing 50 C5. And you'll notice that answer matches. So both methods are equally valid. Pick one that makes more sense to you and run with it. All right, so we know how to handle situations where order doesn't matter. Now we're going to look at situations where it does matter. And in that case, I need to consider duplicates. So if I'm looking at n items and all of those items are different, I get NPR, which looks very similar to NCR, except the R factorial is missing from the bottom. So this has a very similar structure. N is the number of total items, if I can spell. And then R is the number of items we're choosing. And on the right side, we have our fraction with factorials in it. And we access that NPR on our calculator exactly like we did in CR. We go to math, we go probability menu, and then we just want option 2, NPR. And the rules for the old type system are the same. If you have an older model calculator, you'll need to enter the number for n before you go to NPR. If you do have duplicates in your set, so for example, if I'm assigning roles for a play, and 2 of the roles are the same thing, I have 2 characters that are basically playing trees in the background, I have to account for the fact that 2 of those roles are the same. Because the order for those 2 doesn't matter, but the order for everything else does. So in that case, we do n factorial divided by r1 factorial times r2 factorial times rk factorial, where this is the number of times object 1 is repeated. And if I were to add all of those r's together, I should get the total number of objects. So R1 plus R2 plus all the way out to RK should equal n. You will notice sometimes that won't happen because we know that 1 factorial is 1, and multiplying by 1 doesn't change anything, so sometimes mathematicians will be lazy and drop those 1 factorials. So if you see a fraction that doesn't quite make sense, that's probably what happened. But let's go ahead and do 2 more examples, and then we'll be done with this video. So first example says, list all of the permutations of the letters in the word math. This problem was nice. It said permutations. I know it's a P. Math doesn't have any duplicates, M-A-T-H, so I need to identify the number of items, the number I'm choosing. So I know it's a P. In this case, there are 4 letters in the word math, and they're asking me to list all the permutations of those letters. I'm choosing 4 letters from that list. They're asking me how many ways can I order those 4 letters. That's 4P4. I'm choosing all 4. So we're going to go ahead and use the formula and then the calculator. This is no duplicates. So this one is n factorial, n minus r factorial. So n factorial divided by n minus r. 4 minus 4 is 0 factorial. So this is just 4 times 3 times 2 times 1 over 1. 0 factorial is defined as 1. And we know 4 times 3 is 12, times 2 is 24. Let's check that on our calculator. So on the calculator, we're going to go math, prob, whoops, wrong button. Math, prob, option 2, and we want 4p4. And we get 24. Yay, I know how to do math. All right, next example says 7 elementary students are selected to give 3-minute presentations on what they did during summer vacation. How many different ways can the speakers be arranged? So in this case, I have 7 students. Students are all individual, right? Everybody's different. So I know this is a no repeats. We're doing a P. I have 7 students to choose from, and I want to arrange all of those speakers. This is another 7p7, just like 4p4, and we have an idea of what that should look like. N is 7, 7 factorial. N minus r is 0, 0 factorial. We know the bottom's just 1. The top is 7 times 6 times 5 times 4 times 3 times 2 times 1. And that's one I don't want to do in my head. So we're going to grab our calculator and use the shortcut. So math, maybe. And we get 5,040. So if I have 7 students and the order that I present them in matters, there are 5,040 ways I can arrange those students into different orderings. All right, last one. It's word permutations. How many permutations can be made using all the letters of the word Massachusetts? Again, they were nice in that they told me it's a permutation, but Massachusetts has duplicates. So to do this one, I need to do the duplicate formula. And that's n factorial over r1 factorial, r2 factorial. I need to look at the number of repeats of each letter. So first, let's start with the number of letters in Massachusetts that are different. I have M, A, S, another A, a C, H, U, another S, an E, a T, and then another S. And then below that, I'm going to calculate how many times they appear. So there's 1 M, there's 2 A's, there's 4 S's, 1 C, 1 H, 1 U, 1 E, 2 T's. And please double check. The total number of letters is 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So to find the number of permutations, I'm going to build my fraction. I know the bottom fraction is going to be big, the top is going to be tall, so small rather, sorry. The numerator is just n factorial, 13 factorial. And then the bottom is the factorial of all of those numbers for the repeats. 1 factorial times 2 factorial times 4 factorial times 1 factorial, and it's going to get long here. And then there's 3 more ones. 1 factorial, 1 factorial, 1 factorial, and then I've got a 2 factorial. I'm going to simplify this because I know 1 factorial is just 1, and anything times 1 is itself. So those 1s aren't really going to play a role. So I've got 13 factorial over, and then I'm just left with the factorials that are not 1, which are 2, 4, and 2. So 2 times 1, 4 times 3 times 2 times 1, 2 times 1. And this we do need to put in our calculator. So let me pull my calculator up and show you a shortcut for these factorials. You'll notice we're in that same menu, Math Prob, and there's the factorial button, option 4. So I'm going to go back to the home screen and I'm going to start setting up my fraction. In the numerator, I want 13 factorial. And then in the denominator, I want 2 factorial times 4 factorial times 2 factorial. And we get 64,864,800 different orderings of the letters in the word Massachusetts. All right, so that's it for permutations and combinations. I do want to make a short note about the use cases for these. We're using all of these to find the numerators in our probability fraction. So in the last video, we talked about the fundamental counting principle. That helps us find the sample space, which is the bottom of the probability fraction. Combinations and permutations are usually helpful in finding the numerator. How many ways does this specific event occur? And that's the top of our probability fraction. All right, that's it for this video. If you have questions, send me an email. Otherwise, I will see you in the next video.